welcome to True Projects. In this video, we are going to explain about the project that is an explainable and resilient intrusion detection system for Industry 5.0. Before getting into the execution, first let us understand what is the project about. Industry 5.0, often called the fifth industrial revolution, it is essentially the next big leap forward from the Industry 4.0. The key difference here is that Industry 5.0 focuses on bringing together human creativity and advanced machinery. It is not just about the automation anymore, it is about making machines smarter and more collaborative so they can work alongside the humans in a way that is more efficient and intuitive. Think of it as blending the best of human ingenuity with the precision and power of modern technology. Now, here is an interesting part of this is how consumer technology plays a huge role. Devices like smartphones, wearables, and sensors are not just for the personal use anymore, they are actively integrated into industrial systems. They help collect data in real time, monitor processes, and even control machinery remotely. This makes operations smoother and more responsive. And here the problem is with all the interconnected devices is Industry 5.0 systems, they are more exposed to cyber threats. Traditionally, security methods like passwords or basic encryption, they are not just enough anymore because attackers are getting more sophisticated. So while Industry 5.0 is all about innovation and efficiency, it also brings new challenges in terms of keeping these systems safe from evolving cyber risks. Here, intrusion detection have become a crucial issue. So here, intrusion detection systems have become a crucial in protecting network, especially in environments like 5.0, that is Industry 5.0, which is becoming more interconnected and automated. Deep learning, that is DL based ideas, are great at identifying complex, but they aren't very transparent. Here, the problem is with the transparency. This means it is hard for security experts to understand why the system flagged something as an intrusion or how it made certain decisions. Without this clarity, it is tough for them to trust the system fully or to improve its performance. So there is a really need for a new kind of ideas that not only detects threats effectively but also makes its decisions understandable and actionable. By doing so, it can help security teams refine and enhance the system, providing more robust protection against ever evolving cybersecurity risks. So the system that we are proposing, that is proposed in this project, is designed to be both explainable and also resilient, specifically for Industry 5.0, where everything is connected and automated. In such an advanced industrial setup, where different systems and devices communicate in real time, it is crucial to have intrusion detection system that not only identifies cyber threats, but also helps us in understanding how and why it is made particular decision. So to do this, we are employing powerful deep learning models that are bidirectional long short term memory, that is by LSTM, and bidirectional gated recurrent unit, that is by GRU. So these models are excellent at understanding patterns and relationships in the time sequence data like the flow of network traffic. They look at the data from both the directions past and future to get a more complete picture of what is happening in the system. Then we connect these models with fully connected layers, which help to ensure that we can accurately detect and even the most complex cyber threats. Essentially, it is like having a smarter system that not only detects problems but also explains how it has arrived at its conclusions, helping security teams respond more effectively. And deep learning models, they often seen black box. They are often black box. So, where decision making process isn't clear, to address this, here we are using SHAP, that is sharply additive explanations, to show which features influence the model's decisions, making it more transparent and trustworthy for security analysts. And we have trained and tested the system using CIC IDS CIC DDoS 2019 dataset, which includes various cyber attacks to ensure the IDS can detect both known and evolving threats. And the system performance is measured using different metrics that are accuracy, precision, recall, and FN score, ensuring it effectively detects cyber threats while being interpretable and reliable. So this is about the proposed system. So to further improve the performance in this project, we are incorporating ensemble method, voting classifier, and the other method, hybrid method, that is CNN with LSTM. So voting classifier, this method combines predictions of several individual models, which makes the final decision more robust and reliable. By leveraging the strengths of each model, the overall performance in detecting cyber threat also improves. Then comes to the CNN with LSTM. So this approach is introduced. Here, it combines CNN, that is convolutional neural network, and long short term memory, which is particularly effective for sequential data. CNN is great for extracting features from the data, and LSTM captures temporal dependencies, which together enhance the system's ability to detect complex patterns in the network traffic. On top of that, here we have built front-end using Flash framework. So this is basically user-friendly part of the system where people can interact with it directly. We have also added user authentication feature too, which ensures that only authorized users can access the system. This isn't just about functionality, this is about security too. And now users they can log in and test the system and they can see how the model performs. Moving on to the implementation part, to implement this project, we have followed the steps mentioned in the flow of work. So first, we have imported all the required libraries that are NumPy, Pandas, Matplotlib, scikit-learn for data processing, model building, and visualization. Then comes the exploratory data analysis part. So here in this step, we load and examine the data set, which includes various network traffic features and labels related to cyber attacks to understand the data structure and identify useful features for the model. So here we do the exploratory data analysis. Then comes data processing. So here in this step, we remove any duplicate entries from the data set to ensure that model isn't biased by repeated records. Then comes drop cleaning. So this step involves dropping irrelevant or unnecessary columns that won't help in model predictions. Coming to normalizer. Here we normalize the features to bring all the data to a similar scale, which represent improving the performance of the machine learning model. Coming to data visualization. So here in this step helps to understand the distribution of the data and spotting patterns. We plot histograms and heat maps to identify trends in the dataset that can inform about the model building process. Then comes the label encoding. So here in this step, we convert all the categorical labels that are attack types into the numerical values since machine learning models work better with the numerical data. Coming to feature selection. So in this step, we select the best, most relevant features for model building and irrelevant or redundant features are removed to improve the model performance. Then comes data splitting. So here we split the data into two sets. One is training and the other one is validation. Training set is used to train the model and validation set is used to evaluate the model on unseen data. And in the next step, that is building the model, here we initiate all the models that we will be building and that will be trained with the training set of the data to learn parameters to learn patterns. So during training, the model learns to associate input features with the target labels such as attack or normal traffic. And all the models are evaluated using accuracy, precision, recall, and FN score, and they are compared through the graphs. Coming to the part of front end, so we developed a user-friendly interface using Flask where users can log in and interact with the system. The user credentials are stored securely in the SQLite3 database. And in the front end, that is the users, they will be able to provide the input feature values and that will be pre-processed at the back end. It will be fed with the trained model. Finally, outcome will be displayed through the front end of the application. So this is how we have implemented the project. Moving on to the algorithms used. So these are the algorithms used in this project. These three are the extension models and these are the proposed models. These two are the proposed and these two are for comparison purpose. So these models are trained for detecting the intrusion attacks. Moving on to the requirements, to implement this project, we need basically two types of requirements, that is hardware and software. Coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let us execute. To execute, we are supposed to open the code folder that contains source code files. So let us open the code folder of the project. These are the source code files in the code folder of the project. Let us understand each of them, how will they be used in this project. So open the archive folder. In this we have data set. So these are different files we will be combining and pre-process the data set. So after combining all these files, after extracting the raw data, then we will be pre-processing. After pre-processing, the data is stored in this XLS format. So it's being loaded. Just wait for a while. Until it opens, let's check with the other files. So here in the static folder, we have CSS, JavaScript, Bootstrap files, which are important for the visual appeal. And here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is app.py file. This .py file contains information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. This is the model file, which contains the algorithm information, and that will be stored in this SAV files that is stored in this model file, and this will be loaded into the project code during runtime of the application. This is the notebook.ipynb file. This is a Jupyter notebook file which contains combination of code, graphs, and outputs. All are written in one place. So it allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is a sample file in which we have test cases that we will be using in the front end. This is the signup.db file. This file is a database file which is used to store the user information. So this is all about the code folder. Dataset has been opened. Let's open it. So this is the dataset used to train the models, and these are different features. And here in the last column, we have the target class where we will be predicting different types of attacks. So these are the attacks and these are all the features that we have in this data set. We will be training model based on these features only. Now close this. Now let's execute. So to execute, we have to copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Now open the Anaconda prompt. So it is open. Give the command cd, give the space, paste the copied path. Now click on enter. Here, if you observe, current directory is changed to the code folders path. Now compile app.py file. So give the command python space app.py and now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So this is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Paste the link here, click on enter. This is the web page of the project which is displayed in the browser, and this is developed using Flask framework. So we need to sign up first. So click on register and enter all the sign up details if you are signing up newly. I have already signed up, so I'll directly sign in. Click on sign in. Give your username and the password. Click on sign in. We have signed in successfully and we are redirected to prediction page of the project. So here you can see parameters, right? These are the parameters that are supposed to be given. Based on that, we will be getting the predictions. So let us understand what are these. So the first one we have is the flow duration. It is the total time in seconds that a flow lasts. It measures how long the communication between two network devices are, that is source and the destination. Coming to forward packet length total, it is the total length in bytes of all forward packets in the flow. Forward packets are those sent from the source to the destination. Then we have forward packet length max. It is the maximum length of a single forward packet in the flow. This indicates the largest packet in terms of data size. Coming to forward packet length mean, it is the minimum length of a single forward packet in the flow. This indicates the smallest packet sent from the source. Coming to forward packet length mean, it is the average length in bytes of all forward packets in the flow. It gives an idea of typical packet size sent from the source. Then we have flow bytes. It is the rate of the data transfer in the flow measured in bytes per second, and it tells how much data is transferred overall over the network per unit. Then we have flow packets. So it is the rate of the packet transfer in the flow measured in packets per second. It shows how many packets are being sent per unit of time. Then we have flow IAT mean. So this is the mean average inter-arrival time between packets in the flow. So the next one we have is flow IAT STD, that is flow IAT standard deviation. So this is the standard deviation of inter-arrival time. It indicates the variability in time between packets in the flow. Then we have flow IAT max. It is the maximum inter-arrival time between two packets in the flow. It measures the largest gap between any two consecutive packets. Then we have flow IAT total. It is the total inter-arrival time for all forward packets in the flow. It is the sum of the times between each consecutive forward packet. Then we have flow IAT max. So it is the maximum inter-arrival time between two packets in the flow. It measures the largest gap between any two consecutive packets. Then here we have forward packets. So it is the rate of the forward packet transmission in the flow measured in packets per second. It shows how many packets are sent from the source to the destination per second. Packet length min. It is a minimum length in bytes of any packet in the flow. It indicates the smallest packet in the entire flow. Then we have packet length max. It is the maximum length of any packet in the flow. It indicates the largest packet in entire flow. Then comes packet length mean. It is the average length of all packets in the flow. It gives an idea of the typical packet size across the entire flow. Then we have average packet size. It is the average size of the packets in the flow. It provides a general view of the typical packet size in flow. Then we have average forward segment size. It is the average size of the forward segments in the flow. It represents the average amount of data sent in each forward packet. Then we have subflow forward bytes. It is the total number of bytes sent from the source to the destination in the forward subflow. It measures the total data in forward direction from the source. So this is all about the parameters. Now let us enter them. For that, we are supposed to open the sample file. Open the sample file. So we are supposed to give these as the inputs. Let's apply filter to the label column. So let's apply filter. So totally here we have 8 different classes that we will be predicting now. So let's apply filter to the class 0, click on OK, and let's enter the values. Let's try with this case where the flow duration is 2644254. Then we have forward packet length, that is 1200. And the next three values are 300, that is forward packet length max, length min is also 300, and mean value is also 300. Then flow bytes are 45.3, so paste it. And flow packets is 0.015. Flow IT max is, flow IT mean is 8814171. And the next one we have is forward IT standard deviation, copy it, paste it here. And then we have forward IT total, so paste it. We have we are supposed to enter this value, so that is forward IT max, and then forward IT total is this. So here we are supposed to paste that. And then we have forward IT max, paste it, and forward IT packet length. It is 0.15. And the packet length, mean, max, and min are 300. So give them as 300. And the next value is 375. Argument size is 300. 1200 is the subflow bytes. Now click on predict. So this given input, it will be pre-processed at the back and then train model will be giving us a prediction. So here we got the prediction that there is no attack detected. It is benign. So here class 2 refers to benign. Now let's check with the class 1. Select class 1 and click on OK. Now let's try with this case. Click on prediction. So flow duration is 1. Forward packet length is 2912. And forward packet size is 1456. For the next three values is also same. And then flow bytes are 3e plus 09. So copy it and paste it. And the flow packets are 2 lakhs. Sorry, 20 lakhs they are. And then min is mean is 1, 0 is standard deviation, 1 is max. And then we have forward IET max, total is also 1, max is 1. And then we have forward packets that are 20 lakhs. So give it, write it here. And then we have packet length max, that is 421456. We have next three values also same, so just paste them. And then we have average packet size is 2184 and average forward segment size is also 1456. And the next value is subflow bytes are 2912. Now click on predict. So here we got the prediction that there is an attack detected and the attack type is LDAP attack. So it is LDAP attack has been detected. Now let's check with the class 2. Let's apply filter to class 2 and click on OK. Let's try with this case. So I have entered all the parameters here of class 2. Now click on predict. So here we got the prediction that there is an attack detected and that attack type is MS SQL attack it is. So here MS SQL attack has been detected. Now let's check with the class 3. So apply filter to class 3 and we are supposed to enter these values. So click on prediction where flow duration is 48 and packet length are 314. Max is also 314. Sorry, it is 157. And the next two values are also 157 and 157. And flow bytes. So copy the flow bytes, copy and paste it. And then flow packets are 41,666. And then we have forward IIT mean is 48. 0 is the standard deviation, max is the 48. And then we have next values, that is forward IIT total, that is also 48. And then we have forward IIT max is 48. And then we have forward packets. So copy it, paste it. And then the next three values are 157. That is packet length min, max, and mean are 157. And then average packet size is 235.5. Average forward bytes are 157 and 314 are the subflow bytes. Now click on predict. So here we got the prediction that there is an attack detected and that attack type is net BIOS attack. It is net BIOS attack. So class 3 refers to net BIOS attack. Now let's check with the class 4. Let's apply filter to class 4. Let's enter this case. Click on prediction. So I have entered all the parameters here. Now let's click on predict and see what will be the attack detected. So here we got the prediction that attack is detected and that attack type is port map attack. So your port map attack has been detected. Now let's check with the class 5. So let's try with this case. Click on prediction. So I have entered all the parameters here. Now let's click on predict. And here we got the prediction that there is an attack detected and that attack type is SYN attack. So here SYN attack has been detected. Now let's do prediction for the class 6. So apply filter to the class 6. And here, so these are the inputs that we will be giving now. So copy the flow duration. So copy it. Get back to the application, paste it. And then the forward packet, then total is 1398. And then next we have forward packet length max, that is 390, that is 369. And then the next value is 330, that is min. And then we have forward packet mean, that is 349. And then we have flow bytes that are 129685. I've pasted it. So the next value is flow packet. So pasted, that is 37.15. Flow IIT mean, that is 35886. And then we have flow IIT standard deviation. So paste it here. And then flow IIT min, max. So that is 107610. And then we have the next three values are same. So let's paste the same. And then we have the next value is forward packets, that is 37.15. And then packet length, that is 330. So paste it. And then the next value is 369, 369, 345, 345.6, 432, 349 point. Sorry, we have entered something wrong. So just let us recheck. So this value we have entered it wrong, that we have entered it as 369. So that is 345.6. And then this value is 432. And the next value here we are supposed to enter 349.5. And the last value is 1398. Now click on predict. So here we got the prediction that there is an attack detected and that attack type is UDP attack. So here UDP attack has been detected. Now let's check with the last class, that is class 7. Click on OK. So let's try with this case. Click on prediction. So here I have entered all the inputs of class 7 for this test case. So now let's click on predict. Click on predict. Here we got the prediction that there is an attack detected and that attack type is UDP plague attack. That is UD plague attack. So here attack is detected, and that is UD plague attack. So here we are done with the execution. Now let's check with the graphs. Click on graph. So here we have the sample outcome graph, which shows the class distribution. Here on x-axis we have different types of attacks, and on y-axis we have the counts. So here we can see count of each attack in the data set. And this is the correlation matrix graph. This is the accuracy precision. This is the accuracy comparison graph. Here on x-axis we have accuracy score, and on y-axis we have all the algorithms that are trained for detecting the intrusion. And this is the precision score comparison graph. This is the recall score. This is F1 score. And here we have MCC score comparison graph. Now click on logout. In this page, just by giving inputs to the application, that application will be predicting whether there is an attack or not. If there is an attack, it will detect which type of attack it is. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.